Ever notice how many medications there are for, like, headaches? I mean, the drugstore has rows of them.
Hmm.
But for hearing loss, something that affects millions, the treatment options are, well, kind of limited.
Yeah.
And that's what we're diving into today. The blood-labyrinth barrier, or BLB. Basically, the inner ear's top-notch security checkpoint.
And it is a tough one to get through. This barrier, the BLB, its job is vital. Protecting the super delicate structures in our ears, the ones that let us hear.
So like a vault.
Exactly. A vault, keeping all the bad stuff out, anything harmful floating around in our blood.
Better analogy than that bouncer we talked about before.
Mm.
But this protection, there's got to be a downside, right?
You're right, there is. It's kind of a catch-22.
Mm.
For the longest time, this barrier, it's been a roadblock, a big one, when it comes to creating effective treatments for hearing loss.
I see, because the treatments can't get through.
Exactly. Like trying to get a delivery into a super secure building, the guard's not letting anyone in. Good for security, not so good when you're the one waiting for that delivery.
And in this case, the delivery is the medication that could help.
Mm-hmm.
So how do we get past this security?
Well, for years, all we could do was study it indirectly. Imagine trying to figure out how a lock works, but you can't touch it. Just look at it from afar. What researchers really needed was a way to interact with the BLB directly, see what it would take to actually get past it.
So they needed to, like, study this lock up close, maybe even pick it.
Exactly. And that's where this really groundbreaking research comes in. For the first time, scientists have made a working replica of the human BLB. And get this, it's on a chip.
A microchip like in our phones, but like with the tiny ear on it? Seriously, I am picturing a microchip, like the one on my phone, just with a teeny tiny ear on it.
Well, it's not quite that small, but it's close. Okay, so picture this. A tiny little square, about the size of your fingernail.
Okay, got it.
And on that square, there's a channel running right through it. And it's divided, this channel, by a membrane, a porous membrane.
A membrane. So even in this little chip, there's an actual physical barrier.
Yeah. And that membrane, that's like the heart of it all. That's what's replicating the actual barrier, the one that's between your bloodstream and your inner ear.
Huh. Wouldn't any membrane work, though?
That's the thing. This is what makes this research so cool. They didn't just use any membrane. This one, it's lined with living human cells, the same cells that make the BLB in your own ear.
Wow. No way.
Yeah, so on one side, you've got these endothelial cells. They're like the lining of your blood vessels. And then on the other side, parasites, and those help control what gets through. So they basically made like a tiny living replica of the BLB.
So they have this itsy-bitsy channel, and it has this like lifelike barrier down the middle. And that's how they test if medicine will get through. Just put it on one side, see if it shows up on the other.
Pretty much. They put the drug on, like the blood side, and then they use these super sensitive sensors to watch if it makes it to the inner ear side, like a microscopic security checkpoint. You know?
This is wild.
Yeah.
But how do they know that this mini BLB, how do they know it's similar enough to the real deal?
$1 million question, right? To make sure it worked, to validate it, they put it to the test. They used two substances. Daptomycin, that one's a large molecule, can't cross the BLB at all. And then midazolam, that one's much smaller, and we know that one can get through the barrier.
So one they knew would get stopped and one they knew would get through. Clever. What happened?
Yeah.
So did the chip work? Did those molecules get through?
It worked. The results, they were right on the money. Daptomycin, that big molecule, totally blocked, just like with the real BLB. But the midazolam sailed right through, no problem. Proof that their little chip, it mirrored the real barrier.
That's amazing. They actually recreated it, this super complex thing, on a tiny chip. So what does it mean for, like, treatments for hearing loss? Is this it? The big breakthrough?
It could be huge. Think about it. We finally have this reliable way to test out new medications and see, for sure, if they even get to the inner ear. It could completely change how fast new treatments are developed.
I can see why you're excited.
Yeah.
And it sounds like there are even more possibilities than just testing medication.
Right. Oh, yeah. One thing researchers are really interested in is looking at new ways to actually deliver the drugs. We talked about how the BLB is like a fortress, right? Well, what if, instead of trying to sneak past security, we just airdrop the package right where it needs to go?
Love that analogy. Tell me more.
So now with this chip, they can experiment with like putting the medicine inside nanoparticles, little things, small enough to get past the BLB, or they can even test totally new stuff, like using ultrasound waves to kind of, I don't know how to put it, loosen the barrier a bit, make it easier to pass through.
So finding the right medicine, and the right way to get it where it needs to go.
Exactly. And because they have this BLB on a chip, they can try all this stuff so much faster. It's like their own little testing laboratory right there on that chip.
Seriously amazing stuff. So what's next? What are they most excited about figuring out using this technology?
Well, even though it's amazing, this chip, it's still a simplified version of how the inner ear actually is. So researchers are already trying to make the model even better, adding different kinds of cells to make it even more like the real thing.
Oh, wow. Even more complex.
And, they're also looking at if this technology could help with other conditions that affect the inner ear, like tinnitus or vertigo.
You're saying this one tiny chip could unlock a whole bunch of stuff, treating all kinds of inner ear disorders.
It's incredible, isn't it? This research, it really could change so many lives, helping people hear those sounds they love, all because of this breakthrough on a chip.
That's for sure. This deep dive has totally changed how I think about hearing loss. And it really makes you wonder, what would it be like if we could reverse hearing loss? What are those sounds, the ones we'd want to experience again, crystal clear? Something to think about. That's it for today's deep dive, but keep those brains buzzing, and we'll catch you on the next one.